Okay, something to get us perhaps caught up a little bit is those papers that were handed out to you. I was under the impression they're due today, which they are not. Okay, we'll have them due on Tuesday instead. So we're going to spend a little bit of time, as you can see, reviewing the two different types of reactions that we've been talking about when it comes to plants. There's either one of two pathways that they travel down, and what would that be? Different types of reactions. No, you can keep them. Okay. What's one of two pathways that you would look at that would answer production of ATP in plants? Either goes down one pathway or the other. Yeah, either the light reactions or the dark reactions. So, uh, for some of you, I know in past for people who have studied or not studied but struggle with vocabulary, some people use note cards, flashcards. That's a lot more extra work for you. But if you're not obtaining the grade that you would like, that's an opportunity for you to take advantage of. And you're probably going to see these very similar, almost same questions on your exam here, which will be approximately next week, probably on maybe even on Wednesday. Although one person won't be here next Wednesday, and I won't be here next Wednesday, but to the best of my knowledge, you will not be dismissed for the Dakota Valley Conference meet, which is right across the road at Sunrise Ridge. So we will adjust fire upon next week, see where we're at. Okay, so you had correctly said we've got the light reactions. That's correct. What would the other side be then? Dark reactions, they don't necessarily take place at night. Maybe I misled you with that, but for the most part, that's probably when it's most common. Or this is either, you could say, carbon fixation or the Kelvin cycle. Okay, all would belong over on this side. So if we briefly take a look at page 116, yes, yes, approximately page 116. So we want to just summarize this because there's a lot of information provided on there. So we just want to try to keep this a little bit brief, because I know it's Friday, we've got other things on our mind, but we still have a job to do. And you'll find that out once you get further down the line into your associated career path, which this year's not to say different than any other, but you're setting the stage for some of the classes you'll be taking next year. And what was it that we had a student here earlier said, look to your left, what piece of advice would you give to the rest of the people? What was the answer? Pay attention. Pretty simple, isn't it? I mean, it doesn't require a whole lot of effort. I think when it comes to athletics, I think a really good phrase, it takes no ability to hustle, does it? Or work hard? Probably not. I mean, I think that's pretty axiomatic, kind of goes without saying. You don't have to have a whole lot of talent to work hard and hustle. So that's why you guys are as good as you are in football, right? And we're starting to see a big not uphill swing, but you ladies are doing accomplishments as well. So, in other words, keep up the good work. So, good things are happening around here. So, on page 116, okay, as you'll notice up on the top of the page, it's talking about converting light energy to chemical energy. And that's why we're referring to this as the light reactions. So, We just want to go down to the bottom where it has that little blue number 1, and just follow along. And one of the things, maybe I'm just taking presumption here. I don't like to assume things, so I think presumption is a better way to look at it. Would you rather listen to me read this, or maybe you'd rather take turns going around the room? Which do you prefer? Just follow along? But maybe I'm not that good of a reader. Maybe you people are better. Are you better at just doing this yourself? Or you just like following along? Follow along. Okay, asked and answered. Okay, so on the bottom of page 116 it says, in step 1, light energy forces electrons to enter a higher energy level in the chlorophyll A molecules. These energized electrons are said to be excited. Okay, so what we see happening, the best way to look at this, we just want to make some simple summaries here. Just had a marker. Hiding from it. Okay. So in step 1, these electrons get excited because they got split. So what molecule do we need, plants and animals have to have to survive? Very simple molecule. Well, that's the end product. Someone said it over here. Yeah, so what we want to say is water is split. Okay? Because when that happens, the light energy, the leaves absorb that and splits that water, and now the electrons are going to be in an excited state, because one of your vocab terms was this chain, called the what? The electron transport chain. So when this water is split, now we got some free electrons to float around. Okay? So, what we see happening then, as we go over to page 117, we'll just go up to the top. The excited electrons have enough energy to leave the chlorophyll A molecules because they have lost electrons, because that water molecule was split. And we're not worried about the oxidation or reduction. Remember, okay, that's talking about reduction. So, some substance must accept the electrons that the chlorophyll A molecules have lost. As shown in step 2. The acceptor of the membrane is called the primary electron acceptor. Okay, so we're ready to enter electron transport. I'm just going to put ETC, because that's what it was on your vocab quiz as well. Enter electron transport chain. Okay? That is in essence what we're doing in step 2. In step 3, the primary electron acceptor donates the electrons to the first of a series of molecules located in the thylakoid membranes. These molecules are called the electron transport chain because they transfer electrons from one molecule to the next. So this water molecule is split. It enters the electron transport chain. Okay? And again, we're just doing a summarization of this rather than looking at this whole long paragraph. Let's try to simplify this. Okay? So we got the transfer of one electron to the next. Okay? So this is, we got a whole, just think of a chain. An electron is going from one electron to the next, to the next, to the next. Thank you, Mr. Tim. He's a good mechanic, isn't he? Change the oil on that Avalanche. I was afraid he might forget because maybe he's excited going up to Esteline tonight. So, looking forward to tonight, gentlemen. Just like every Friday night, probably. And, one step at a time. I'm sure that's how you look at it as well. Just one step at a time. Okay? Now, we're ready to head to step 4. Okay? Step 4, light is absorbed by the photosystem. We're not too concerned about that. This happens at the same time light is absorbed by photosystem 2. Electrons move from a pair of chlorophyll A molecules, blah blah blah, but electrons lost by these, blah 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 blah. The primary electron acceptor donates the electrons to different transport chain. Okay, so what we are concerned about in steps 4 and 5, again, just to simulate or summarize this, we'll just put them together, because as that electron gets passed along the chain, the reaction causes NADPH to be produced to NADPH. But, in other words, when this happens, at the end, ATP is produced. Okay. So, hopefully we can see the value in this. Rather than looking at that whole long, lengthy paragraph, this is what we want you to know in the electron transport chain. Let's simplify that. Let's not try to make this too terribly difficult. Okay? So, let's move forward to page 121. Or 120, sorry. So, we'll hit this again. Chances are, if you're writing this down, you're probably doing yourself a favor, but it is a personal choice. Okay, page 120, carbon fixation. Okay, notice what else we have up here: carbon fixation, Calvin cycle, sometimes referred to as the dark reactions. I think it's just more simple to look at it that way because we call these the light reactions, so just the opposite, you would just call them the dark reactions because it doesn't necessarily have to take place during the daytime. So, in this case, page 120, the Calvin cycle is a series of enzyme-based chemical reactions that produces 3-carbon sugar. In the Calvin cycle, carbon atoms from CO2 in the atmosphere are bonded or fixed into organic compounds. This incorporation of CO2 in organic compounds is called carbon fixation. A total of 3 CO2 molecules must enter the Calvin cycle, and blah, blah, blah. I think you would agree. So, in step 1, CO2 diffuses into the stoma from surrounding cytosol. Now, what does it mean to diffuse? Okay, what did we talk about last chapter? What are examples of movements of molecules? Obviously, there's diffusion, there's osmosis, there was facilitated diffusion and active transport. But, in this case, simple diffusion. Okay? Diffusion of CO2 into the stoma. Is that what it was? Stroma? No. From the stroma. Okay? One of the things that we talked about when it's hot during the day, these stroma are little openings. They open and close, open and close. So what that means is during the day when it's hot, that stroma, is that going to be wide open or is it going to be shut? It's probably going to be shut because it saves water, because later on when temperatures cool off, that can then open up. Chances are when it's dark out. So diffusion of CO2 into the stroma. Okay? And then in step 2, it has a lot of biochemistry in there. We're not so concerned about that. We just want an overall picture of this. So the last half a sentence is talking about and phosphate that are also produced can be used again in light reactions to make more ATP and ADPH. Okay? So, as this CO2 is converted, is allowed into the stroma, step 2, we just want to summarize that in step 2 and step 3. That. Okay. So carbohydrates are made for later use. Made later use. Okay. Now we'll just wrap this up in step 4. Calvin cycle can be repeated again. Repeat again, or be stored for light reactions. Okay, so in essence, that's just a short, drawn-out version of what's happening in dark reactions. That stroma is opening and closing, allowing CO2 to come in. So when that happens, carbohydrates are made from that carbon dioxide. So then, this can just continually repeat as long as you have carbon dioxide coming in, because as daytime would approach, if those are wide open at night, now all of a sudden the sun's coming up, it's starting to warm up, those little structures are going to start to do what? They start to close. Why? You're right, but why are you right? Do what? Yeah, they want to conserve water. That's right. So then it can start producing energy this way by the split of water. So it's just a continual cycle. Light, dark, dark. Okay? So hopefully we're not too intimidated by this. We're just trying to summarize this to make it just as simple as possible. All right. So next Monday and Tuesday we'll talk about cellular respiration again, wrap everything up, get our exam, and get into protein synthesis. We'll catch up to you next time.